Alright, hell yeah. So we have material mechanics. Now this problem was a bummer because it involved springs and I was kind of getting everything wrong on it. So what I'm going to do is just with the wave of my hand kind of go through here. So I'm going to do a free body diagram. And this problem I'm going to solve it without really, diving into what I'm doing or what's going on. Or just enough, you know what I mean? So every stroke of the hand I'm going to be doing, something new. So we have a load here. Essentially we want to make this horizontal. What we know is that, let's go to it. We know forces in the Y are the same. So F1 plus F2 is equal to P plus W. We got the force balance. We're going to take moments about this point. Positive moment there. F2, the total length, is going to be equal to W L over 2 is halfway, plus the load P times X. Now this is a positive, both those are negative, so we can equal. F1 and F2 are positive, both these are negative, but they're equal. Cool. Alright, but now we need a relationship with springs, and the first thing we need to know is like, whoa, what's going on here with the geometry? Geometry is king for all mechanical engineering problems. So we have, I'm going to start here. I'm going to say H plus the initial length of this spring. I'm going to call that L2 now, whatever the hell it would be, plus the change in length of that spring gets me to that point. Well, guess what? It's going to be horizontal at this point. So I'm going to start from the same datum and say that's going to be equal to the length of this spring, L1, the initial length, plus the change in length of spring 1. Cool. So now we have another equation. But now I need to know what the forces are. The forces right here and right there are just due to these springs. So I know the force of a spring is Kx. I say that's force K times change in length. So that's kind of what we're going to do. We're going to say F1 is spring constant 1, change in length 1. Well, cool. Don't we have a change in length there? Hell yeah, we do. And then we got F2 is equal to K2, change in length 2. Cool. Now, even like right now, we got 1, 2, 3, 4, 5 equations. Do we have enough? Because this was the king on this one. It involves this H. Sorry about the light. Let's get some new light in there. And hell yeah, we're 2.5 minutes in. So booyah. Let's count up our unknowns. 1, 2, 3, and then 4, 5. Is that it? 1, 2, 3 unknowns there. 4, 5 unknowns there. Oh yeah, there you go. So we got 1, 2, 3, 4, 5 unknowns and only 3 equations. But now we have the same unknowns. See how that pops up. So yeah, we got 5 unknowns, 5 equations. So let's get to it. I always know to work backwards with these. You know what I mean? So I'm going to throw... I want to get this equation with the forces. See how this is a force? So I'm going to say, hey, change in length 1 is F1 over K1. Change in length 2 is equal to F2 over K2. Now we can just get rid of these two. See how I can do that? So this equation is going to go H plus L2 naught plus F2 K2 is equal to L1 naught plus F1 K1. Cool. So now I combined all 3 of these equations, and I got this new equation. I'm just going to call it 3 prime because that reminds me that I used 3 and 4. Cool. So now I'm going to take this equation, and now I got three equations left. So the smart thing to do is realize that this is the equation that has the x in it, where my load is going to be. I didn't even explain this problem. So it doesn't really matter. Well, no, it kind of does. But essentially, this spring is mounted way low, where its initial length is hella down here. So this thing naturally is resting like that. And then we have to put the load to balance it out. So even just doing that, if you can see that from the numbers, you know that the load has to be this side of halfway. So let's just guess. If this is 350, I'm just going to say the load is, let's say 100. That's what I'm kind of shooting for. Okay, now that's enough, and let's just solve the problem. Because that's the hardest thing, is just like, hey, how do you actually solve a 5-equation problem? Well, we're down to 3 equations. So now we just have 1, 2, and then this x is our third unknown. So this is an equation that we want to use last. This equation has f2 in it. So we want to make sure that this equation has f2. So we need to throw an f1 in. So we need to solve this equation for f1, throw it in here, solve that equation for f2, throw it in there. So yeah, it's a little bit headachy. So what I do is, I don't want to write very much, so I'm just going to say, hey, we have an equal sign here. Guess what? Now we have an equal sign here and a minus sign there. You know what I mean? You can go back and see what I did. But and now we just multiply by k1. So I'm just going to do this and go k1. So now we have f1 as a function of f2, and I'm going to throw it in here. So I'm going to take all this now. I'm just going to say, hey, it is up there. I'm going to go, booyah, there it is. Plus f2 is equal to p plus w. So hell yeah. So now I have this. So now I really have to kind of factor through this k1. So we have h k1 plus L2 naught k1 plus f2 k1 k2 minus L1 naught k1. Everything's got a k1 plus f2 is equals to p plus w. Okay, so now I need to round up the f2s and get all these over here. So even just like right now, I'm just going to be like, hell yeah, plus L1, oh, what the hell was that? L1 naught k1. And then I'm going to go minus L2 naught k1. And then I'm going to go minus hk1. Perfect. They're all over there. Everything else is f2. Visually, I can see it. f2 is k1, k2 plus 1. And then I'm just going to divide all that by k1, k2 plus 1. Cool. So let's write this out. Maybe on a new sheet of paper, but maybe just right here. And so we have f2 is equal to, well, p plus w plus L1 naught, k1 minus L2 naught, k1 minus h k1 divided by k1, k2 plus 1. But yeah, we definitely need a new sheet of paper. So let's get that written up here, and we got f2. Well, we gotta. I'm just gonna totally do this now. We're trying to make faster videos, even if it's sloppy. Alright, so hell yeah. So here's our equation that we wanted in, and we need to throw it into this one. So there's our f2. So we're going to take that whole thing and then multiply it by L. Cool, I think we can just do that. Just go multiply by L. And then once we got multiplied by L, that thing's going to equal WL, well, we can subtract that, minus WL over 2. That whole thing's going to equal PX. And then we can just divide by P, and then we got equation for X. So booyah, X is equal to P plus W plus L1 naught K1 minus L2 naught K1 minus HK1. L times P, multiplied this out, divided by K1, K2 plus 1, and then subtract WL2P, and there you go. So there's our equation for X, and that's within 10 minutes, but that's the one that I spent about 3 hours on. I threw it into my calculator. We can even do that. I have alpha P plus alpha W plus L1 plus K minus L2 K minus X for the H, and then K, alpha L divided by alpha P, and divided by K divided by J plus 1, minus alpha W alpha L divided by 2 alpha P. Graph that sucker, and we're going to throw in H at 80. So I'm going to go alpha value 80, and I get my answer at 134. Now, I only have 20 seconds, so you could throw this in. The problem said load 18 plus 25. This initial length was 250. 0.3 for here. I'm not using meters, but anyway, And that's it. I'm done with this video. Thanks for joining me. That's a video.